Okay, so let's label things clearly. This 1.0 meters per second in the j-hat direction, this is the velocity of the person relative to the raft. And so that is 1.0 meters per second j-hat, meters per second times j-hat. Whereas the velocity of the raft is going to be 2.5 meters per second j-hat. A couple of things I want to mention. One is the key to solving these relative velocity problems simply is to label things very precisely. So when I say 1.0 meters per second j-hat, you say very explicitly person relative to raft. And then say this is the velocity of the raft, 2.5 meters per second j-hat. Now you might be asking the question, what about the riverbank? Well, the thing is the riverbank doesn't move. So I'm not bothering saying anything relative to the riverbank. We're just saying that's the velocity of the raft, and so it's implied it's relative to something that's not moving, which is the riverbank. Okay? So what is it we're looking for? We're looking for the velocity of the person, or if you want to be more precise, relative to the non-moving riverbank, what is the velocity of the person? Okay, so we want the person. So we have the raft, 2.5, sorry, made an error here. It should have been 2.5 meters per second I hat. Hopefully there was an immediate response, somebody in the class saying there was a mistake in the video. It should have been I hat. Okay, so we want to know what is the velocity of the person. Okay, but we know the velocity of the person is equal to the velocity of the raft plus the velocity of the person relative to the raft. Okay? The velocity of the person is the velocity of the raft plus the extra amount that the person is moving relative to the raft. Okay, so now let's write this out. This is 2.5 meters per second I hat plus 1.0 meters per second j hat. Okay, so those are the components of my vector. So now we're just doing a little bit of trigonometry. So we have plus y direction plus x direction, and I have 2.5 per second for the x component, and then I have 1.0 meters per second for the y component, and so this will be my velocity of the person. And I might want to know this, well, I do want to know this angle in this right triangle. So the speed, or the magnitude of the velocity, will be the square root of the sum of the squares, 2.5 squared plus 1.0 squared. This comes out to about 2.69 meters per second. If I want to know the angle, it will be the inverse tangent of AY over AX, and this comes out to 21.8 degrees. And this inverse tangent from my calculator is actually correct. It's in the first quadrant, so this is the right angle that I want. Okay, so if you have any questions, go ahead and ask them. Otherwise, I'll see you guys tomorrow.